Let's see. So I remember back in 1998, Greg Burns came up with some coffee cups for ARFTG, and they were around 25 years of microwave measurement excellence. Well, I think we've got 40 years at this point. We've got over 1,700 technical papers, and what I did, Ken asked me to take a look at IEEE Explore, which I did, and if you do a search, you can get a listing of who published the highest number of papers right off the bat. And I know that Harold Steinhelfer was mentioned, but I think the top person was actually Larry Dunleavy, who's not here today. Let's see, Dominique, close second, and on down the line. So a lot of people that are in this room have made major contributions. We don't really have a listing of the first 10 years. Let's see, so we've always had a conference theme. We've had key vendor products, theoretical papers, experimental, always practically oriented, measurement comparisons, and the most important part, I think, are the long-lasting relationships that we've had among the members, which go on to this day. I won't say too much then about the first decade or so. I think John covered this pretty well, but these are some of the themes that I was able to uncover as I went through this. And by the way, I started on this a couple months ago. I read through just about every abstract, and I got sidetracked quite a bit because there's so many good papers that it was hard to drag myself out of reading papers and get on with the show. So what I did is I tried to take all the data and dump it into a data analysis program and search on keywords and which ones ended up being there the most times to try to come up with some major themes. It turned out that it was impossible. But what I was able to do is to extract these as the real major themes that have occurred in ARFTG through the years. And what I'm going to do over the next couple minutes, and I know we're running late, is I'll try to hit on some of those key themes for you. The first is we've always been concerned with connector technologies, and ARFTG has been the melding place for studies of these technologies. And you can see the introduction of those various connector types through the ages. There was a paper back in 1984 by Peter Lacey of Wiltron, and he showed the evolution. And you can see that has continued on. We're still working on 1 millimeter and W-band calibration kits and so forth. I don't think we're going beyond that. And another big theme has been calibration, error correction, verification, measurement uncertainty. We started out with open short load through. The first paper on TSD was by Ross Especial of TRW. We started getting into on wafer cal in '88. And there have been so many different variants of LRM, LRL, et cetera, from the early 90s through the present day. Dr. Reynoso Hernandez and Dylan Williams, I think, who's here, have been key in that. Multiport, Andrea has been really the expert in that domain. We've had papers on embedded calibration and transfer standards, differential calibration, and then optimizing calibration to achieve the task at hand. We've also had some papers on generalization of calibration theory, and those are a couple of the key contributors there. Let's see, as was mentioned, some early work on noise by NBS and NIST, phase noise measurements, noise and gain parameters and different techniques for that. Transistor 1/F noise, power measurements, and different ways of calibrating them, and pulse power. How to do detection, diode detection, and error analysis. Early work on IQ detection theory and alignment, and that's gone on through the years. Then we started getting into sample measurements and convolution and so forth. I found this to be extremely interesting slide that was presented by Bert Burson. This was back in 1993. You recall back in 1991, 92, peace broke out. The Iron Curtain was torn down. And so a lot of us said, what are we going to do? And our VP at HP at the time, Dick Anderson, made this statement. I think this was very prescient. We've entered the Ice Age. And it's turned out to be very true, hasn't it? And this particular slide was really focused around the expansion of the MMIC market. And it's really held together. Just one thing to add to it is that surveillance, of course, has taken off quite a bit post 9/11. But it really pretty well describes the overall domains that we're interested in. One thing before I move on to some other topics, we've had some papers on what I call wireline measurements. Back in the late 90s, there were papers on HFC and characterization of uplinks and cable TV networks. And more recently, papers on time domain measurements for wireline, so signal noise and bit error rate testing and low jitter measurements and so forth. Another focus of ARFTG has been structure and measurements and simulation. Early on, we had quite a number of papers, as John mentioned, on TDR and TDT and inverse FFTs and so forth, and how to use time gating and so forth to identify and remove mismatches. We also had some early papers on EM simulation and their application to near fields and planar standards and so forth and fixtures. And let's see, more recently, a lot of interest in interconnect modeling and for specific applications such as silicon. Let's see, multiple interconnects, packages and coupling, extraction techniques, and recently in the last decade and a half on complex permittivity and permeability measurements, and even into food, blood, and textiles. But what I found is the main focus of ARFTG, not to minimize any of the other areas, from the mid-'80s onward, has really been around semiconductor measurement. So these are some of the major areas, and I'll delve into those just a little bit of detail. I know we're running late. One has been certainly in the area of test hardware. We started out with transistor test fixtures. Gary remembers that. And wafer probes of all kinds. We got into cryogenics, high temperature measurements, and even contactless probing. Another key area has been tuners, passive, solid state, active, calibrated ones. Use tuners in noise parameter characterization, all kinds of different load pull papers and ways to improve accuracy and minimize measurement time, and taking that data and melding it into nonlinear device models. That's been going on recently. And then an area of opportunity, of course, has been in characterizing nonlinearities. So high-frequency semiconductors have all kinds of different interesting characteristics, and read through those. Of course, most of us know about those. amplifier measurements and design. There are over 100 papers that have been published on power amplifiers and ARFTG, multi-tone, multi-carrier, IMD, spectral regrowth, and so forth, prediction and optimization of IQ performance, linearization. I thought this was interesting, use of Doherty amps, because in the 3G and 4G modulation schemes, you have high peak to average ratios. It's supposed to be ratios, not rations, and other types of models. Remember that ARFTG is all about automation, and there's another theme that occurred, and it also involves semiconductor test, and that's with the advent of microprocessors. Remember, we started out with HP 2100 computers back in the 1970s. We got into doing desktop computers, then PCs, then multitasking, multi-threaded controllers. Just take all that stuff for granted, but it has an enormous impact on the cost of test for satellites, power amps. We've had Rus Instruments, HP developed. John was involved in RFIC test. A lot of work in single connection, multiple measurement. A lot of work in known good die and data analysis. There are some papers in the 2002 era around using COM and data file formatting. There was a few in the 1970s and more recently XML formats. And as a lead-in to the next generation, just wanted to mention that millimeter wave measurements are really growing in number. They seems to be pervasive in the types of papers that are being presented in the 2000s and the 2010s. So that's my talk. Thank you very much.